can do 45 or 47.
Yes, you choose, whichever.
Um,
So this is done already. I'm done in class. I'm gonna
47.
47. Okay, very good. So let's look at 47. 47, again, page 314. Okay, 47. F of x equals 30 e to 0.01x and the given interval negative 10, 20. So we don't discuss that. We don't need any to find any domain. We don't care about any of that. So the domain is given to us. It's carved in stone. So this is, of course, f prime and then f of x. So in order to find max min, of course, I have to find critical numbers if they exist. This function is always defined, always. So let's find f prime of x. But of course, we are given negative 10 to 20. So let's find f prime of x. Can anyone help us with f prime of x?
Is it 0.3
Yes.
e?
Yes. 0.3 e to 0.01x. So here is what we just did. 30 times e to this function times the function prime, which is 0.01. And we already multiplied 30 by 0.01, and we got 0.3. So let me write it step by step. So f prime of x is 30 times e to 0.01x times the inner function prime, which is 0.01. When you multiply 30 by 0.01, we get 0.3. Very good. It happens that f prime is always positive, never 0. What does this mean? When a derivative of a function is always positive, what do we know about the function? What does the function do when its derivative is always positive?
It never goes like below 0.
It always increases. Always increases. If the derivative is positive, the function always increases. So the only thing I need to do is just plug in negative 10 and find this value, plug in 20 and find this value. This must be the absolute min, and this must be the absolute max. Guaranteed. If the function is always increasing, at the left end of the interval has to have an absolute min, and at the right point of the interval, at the end point of the interval on the right, has to have the absolute max. It's always increasing. So we'll punch it in the graphing calculator. So in y equals, we punch in 30 e to, where is my e? Right here. 0.01x, close the parenthesis, and just punch in negative 10, whatever I get, I don't even care, and positive 20, whatever I get, I don't care. So since I want 2 decimal digits, I can see I don't really need to look at more than 3 digits, right? So 27.15. And the other one is 36.64. That's it. We study the function on a closed interval. Now, if the function also goes down, then it's a different story. I may have an absolute max here, who knows? But this function has no critical numbers. This is never 0. And it's always positive. Very interesting pick. Thank you. Is that clear?
Yes.
Perfect. So this was absolute maximum. Don't forget, you need to present a table. You need to study the sign, if it does whatever it does. And also always determine the function value at every critical number, including the endpoints. So this was absolute max, absolute min on a closed interval. Okay. What do we continue with? We have to graph showing everything, and max min is also included in the graph, but it could be something else, just a function that we don't need to graph. So this includes this. So let's find the function and show everything. This was in 3.3, page 305. Oops. 305. Okay. We graphed both, I remember 43 and 44. That I remember. Let's graph 17. 6x over 8x plus 3. I'm going to change it a little bit to make it more friendly. I'm just going to put x at the top and 8x plus 16 the denominator. Just something a little bit friendlier. I hope so. We'll see. Okay. So we're asked to graph using everything, determining everything, and of course summarizing everything in the table. I'll start with my table. F prime, f of x, and f double prime. And this will go to recycle. Okay. Can anyone give us the domain of this function?
It's 8x plus 16, right? Would it be 2?
When we move a term from one side to the other, we have to change its sign.
Oh, -2.
Excellent. So negative infinity, -2, 0, infinity. So at -2, this function doesn't exist. So I know that x equals -2 is a VA, because this factor doesn't go away with anything in the numerator. Can anyone plug in 0 and tell us what to write when x is 0?
0.
Excellent. Because it's 0 over 16, which is 0. Can anyone tell us these limits? Let's write it. Limit of x over 8x plus 16 when x approaches infinity. Where is the numerator going and where is the denominator going?
They both go to infinity.
Excellent. What do we do when we have a situation like this, when x approaches infinity and both top and bottom go to infinity? What do we do? We factor out the degree, but there is nothing I can do to the top. It's already factored, thank goodness. And what do I factor out in the denominator? What is the degree in the denominator? And what do I factor out?
Just an X.
Just an X. Awesome. And now please tell me what you write, what I should write in parentheses, so then when I distribute X, I get this.
8 plus 16 over X.
Awesome, brilliant. And this is what I have to do now. Where is this piece going?
Equals 0.
Yes, this is approaching 0. And what is the limit then? Now, only now I drop the limit operator.
Is it 1 over 8?
Awesome. The numerator goes to 1. The denominator goes to 8 plus 0, which is 8. So I know that this is all I need. Y equals 1 over 8 horizontal asymptote. Awesome. Good. And last thing, I need to determine this. I already know. Since I wrote it's a vertical asymptote, I know these have to be infinities, but I don't know the sign yet. I don't know the sign. So what I'm going to do is write limit as x approaches -2 from the left of x over 8x plus 16, and limit as x approaches -2 from the right of x over 8x plus 16. We know they are infinities. Why? Because x equals -2 is a VA, but I need to identify the sign. So with -2, the numerator is negative. When I plug in -2 in here, I have negative. There is no discussion there. I know that the denominator is 0. No discussion there. -16 plus 16, obviously. But remember, I'm plugging in here right now -2 from the left, like -2.1. So -2.1 times 8 plus 16. Just give me the sign of this. Negative. Which means, what is the sign in front of the infinity then?
Positive.
That's it. Because I have negative at the top and negative in the denominator. Awesome. The same thing here, but I will plug in -1.9 from the right of -2. I only need the sign. 8 times -1.9 if it goes over 16 or stays under. If it stays under, it's positive. If it covers 16, then it's going to be negative.
It's positive.
Good. Now, negative of a positive, what will be the sign here?
Negative.
That's it. So, negative on this side, positive on this side. We finished with the function. Now we are going to talk about the derivative. So let's do that. So I'm going to find f prime. I'm going to factor out 8 here. 8 squared and x plus 2 squared. The top prime, 1. 8x plus 16 minus the top times the denominator prime. Can anyone give us the denominator prime?
Just 8.
Very good. Negative 8x with positive 8x. Awesome. 16 divided by 64, x plus 2 squared. And I'll simplify, and I get 4. So the derivative is 1 over 4 x plus 2 squared. So f prime of x equals 1 over 4 x plus 2 squared. Can this be 0? When is a fraction 0? Always.
When the denominator is 0.
When the numerator is 0. So no. No critical numbers. No critical numbers immediately. I know no max min. Guaranteed no max min. What is the sign of this so I can put it in the table?
Always, that's positive.
Very good, which means the function does what? Always.
Increase.
Excellent. Now I don't know. We'll see what I did here. Who knows? I have to check. If these two don't work well together, I'll say, oops. So from 1/8, 0.125 to infinity, is the function increasing?
Yes.
Yes, and that's supported by the sign of the derivative. From negative infinity to 0, is it increasing?
Yeah.
And from 0 to 1.125, is it increasing?
Yes.
Yes. So now finally the second derivative, and then we can graph. So f prime, I'm going to write it like this, because I think it's easier. So the second derivative, bring down -2, -1/2, times x plus 2 to -3 times the inner function prime. Always say times the inner function prime, always. Okay, so this is -1/2 x plus 2 cubed. But you know I'm going to split this into x plus 2 squared and x plus 2, because I don't want to study the sign of this. There's nothing to study. There's nothing to study for 2. There's nothing to study for this. These are always positive. They will never change anything. So then, what is the sign of the second derivative to the left of -2? And what is the sign of the second derivative to the right of -2? Let's say we don't know. We're going to plug it in. Let's plug in -6. -6 plus 2 with minus in front. What is the sign?
Negative.
-6 plus 2 with minus in front.
Oh, sorry, positive.
That's good. I put the sign immediately. The symbol, not the sign, the symbol. Okay, now let's try 0.
Negative.
Negative. Please put the symbol right away. Good, that's all I need. Everything else is gibberish. Doesn't mean anything anymore. That's all I need. I wouldn't look anywhere else. It will be a waste of time. Good, so I'm graphing the function. First I graph the asymptotes. -2. And y equals 1/8. Well, that's difficult, but let's say this is y equals 1/8. Good. I have 0, 0, and nothing else. So the function opens up, coming from the horizontal asymptote, going to infinity on the left-hand side of the vertical asymptote, from 1/8 to positive infinity. Okay, that's easy. On this side, there is only one point. It's opening downward. It's always increasing, of course, always increasing, but this time opening upward. Always increasing, opening downward, coming from negative infinity, crossing at the origin, and increasing to 1/8. Okay, that's easy. So this is the function x/8, x plus 16.